Hello everyone, welcome to chemistry classes. So today we are going to deal with the interesting bit of this topic. So it's such a wonderful bit. It is important also for your board examination as well as for your NEET and ZEE as well as for KCET examination. Okay, so it's something interesting bit. So the product of electrolysis. Now we are going to deal with the product of electrolysis. On electrolysis, the which type of product we can get by changing some parameters. Okay, so, we'll start with this. The product of electrolysis. The product of electrolysis mainly depends upon two factors. It depends upon mainly two factors. The first one is nature of electrolyte or the nature of the substance being electrolyzed. The type of the substance being electrolyzed means that is the substance is none other than electrolyte. Means the formation of product during electrolysis depends upon the nature of electrolyte. Which type of electrolyte will select the such type of product we are going to get. And it also depends upon one more thing, that is nature of electrode. It also depends upon nature of electrode. Okay, so let us discuss something deeply. If the electrode is inert, inert electrode means what? The electrode which just behave as a platform for the chemical reaction, but it will not undergo into the chemical reaction. So it just behave as the source of electron or sink of electron. Means what? If I take platinum as an electrode, we have discussed about this thing in standard hydrogen electrode, isn't it? So if I take platinum as an electrode, this platinum just behave as a platform for the chemical reaction, but it will not undergo into the chemical reaction, isn't it? So in that case, the chemical reaction is only because of the electrolyte. So the product is formed based on the type of electrolyte we are using. If the electrode is inert like platinum or gold, it do not undergo any chemical reaction. So the product depends only upon the electrolyte. If the electrode is reactive, reactive means what? The electrode is also the part of a member of the chemical reaction. The example is your Daniel cell, isn't it? So in case of Daniel cell, we used to use the electrodes like zinc electrode and copper electrode. In that, zinc electrode undergone oxidation and copper electrode undergone reduction. So being an electrode, if it is reactive, it undergo into the chemical reaction. In that case, the formation of product changes. In such cases, the formation of product depends upon the nature of electrode as well as nature of electrolyte, isn't it? So simply we can say that the formation of product is different for reactive electrode and also it is different for the inert electrode. So the product of electrolysis depends upon the different oxidizing and reducing species in the electrolytes. It is also important. The product of electrolysis, the product formed during the electrolysis, it also depends upon the different oxidizing and reducing species present in the electrolyte. If an electrolyte contains more than one type of oxidizing ions and reducing ions, in such cases the formation of product depends upon those oxidizing and reducing species and the nature of their oxidation and reduction. So here simply you can say that at cathode which reaction takes place? At cathode reduction takes place. If our solution contains two of such ions, the ions which can undergo reduction. So in that condition, the ion which can easily undergo reduction gives chemical reaction. So the product will be the result of that ion. Okay. So like that we can consider. So ಇಲ್ಲಿ ಯಾವ ತರ ಅಂತಂದ್ರೆ ನಾವು ಎಲೆಕ್ಟ್ರೋಲೈಸಿಸ್ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಮಾಡುವಾಗ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ರೆಡಿ ಆಗುವಂತ ಪ್ರಾಡಕ್ಟ್ ಯಾರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ ಅಂದ್ರೆ ನಾನು ಯಾವ ತರ ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತೀನಿ. ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ಅಂದ್ರೆ ಯಾವುದು? ಸೊಲ್ಯೂಷನ್. ಅದರೊಳಗೆ ಹಾಕುವಂತ ಸೊಲ್ಯೂಷನ್, ಆ ಸೊಲ್ಯೂಷನ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ ಫಸ್ಟ್ ಥಿಂಗ್. ಸೆಕೆಂಡ್ ಥಿಂಗ್ ಮತ್ತೆ ಯಾರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ ಅಂದ್ರೆ ಆ ಎಲೆಕ್ಟ್ರೋಡ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ. ಸಪೋಸ್ ನಾನು ಯೂಸ್ ಮಾಡುವಂತ ಎಲೆಕ್ಟ್ರೋಡ್ಗಳು ಇನರ್ಟ್ ಇದ್ದು ಅಂದ್ರೆ, ಇನರ್ಟ್ ಅಂದ್ರೆ ಏನು? ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಮಾಡೋದಿಲ್ಲ. ಅದು ಆ ತರ ಇದ್ದಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ನಾ ತೆಗೆದುಕೊಂಡಂತ ಎಲೆಕ್ಟ್ರೋಡ್ ಇನರ್ಟ್ ಇದ್ದಾಗ ದ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಡಿಪೆಂಡ್ಸ್ ಓನ್ಲಿ ಅಪಾನ್ ದಿ ಎಲೆಕ್ಟ್ರೋಲೈಟ್. ಹೌದಾ? ಸಪೋಸ್ ನಾನು ತಗೊಂಡಂತ ಎಲೆಕ್ಟ್ರೋಡ್ಗಳು ರಿಯಾಕ್ಟಿವ್ ಇದ್ದರೆ ಅವಾಗ ಏನಾಗಬಹುದು? If the electrodes are reactive, in such condition the formation of product depends upon the nature of electrolyte as well as nature of electrode. ಹೌದಲ್ವಾ? ಸೊ ಅಂಡ್ ಆಲ್ಸೋ ಸಪೋಸ್ ನಮ್ಮ ಸೊಲ್ಯೂಷನ್ ದಲ್ಲಿ ಒಂದಕ್ಕಿಂತ ಹೆಚ್ಚು ಅಯಾನ್ಗಳು ಇದ್ವು ಅಂತಂದ್ರೆ, ಎರಡಕ್ಕಿಂತ ಹೆಚ್ಚು ಅಯಾನ್ಗಳು ಇದ್ವು ಅಂತಂದ್ರೆ, ಎರಡಕ್ಕಿಂತ ಹೆಚ್ಚು ಅಯಾನ್ ಅಂದ್ರೆ ಇಟ್ ಮೇ ಕಂಟೈನ್ 4 ಅಯಾನ್ಸ್ 8 ಅಯಾನ್ಸ್ ಲೈಕ್ ದಟ್. ಆ ತರ ಇದ್ದಾಗ ಎರಡು ಅಯಾನ್ಗಳು ಆಕ್ಸಿಡೈಸಿಂಗ್ ಆಗೋ ತರ ಇದ್ವು ಅಂದ್ರೆ, ಎರಡು ಅಯಾನ್ಗಳು ರಿಡ್ಯೂಸಿಂಗ್ ಆಗೋ ತರ ಇದ್ದಾಗ ಯಾವ್ದು ಈಸಿಲಿ ರಿಡ್ಯೂಸ್ ಆಗುತ್ತಲ್ಲ ಅದು ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಫಾಸ್ಟ್ ಆಗಿ ಮಾಡುತ್ತೆ, ಯಾವ್ದು ಈಸಿಲಿ ಆಕ್ಸಿಡೈಸ್ ಆಗುತ್ತಲ್ಲ ಅದು ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಫಾಸ್ಟ್ ಆಗಿ ಮಾಡುತ್ತೆ. ಸೊ ನಾವು ಯಾವ ತರ ಗೆಸ್ ಮಾಡ್ಬೋದು ಪ್ರಾಡಕ್ಟ್ ಅನ್ನ, ಯಾವ್ದು ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಈಸಿಲಿ ಮಾಡುತ್ತಲ್ಲ ಆ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ಅಂತ ಗೆಸ್ ಮಾಡಬಹುದು. ಹೌದಲ್ವಾ? ಓಕೆ. And one more important thing, some electrochemical processes are feasible. So what do you mean feasible? Feasible means they do occur. Definitely the chemical reaction takes place. ಹೌದಾ? feasible ಅಂತಂದ್ರೆ chemical reaction ಆಗೇ ಆಗುತ್ತೆ ಅಂತಂದಾಗ. ಹೌದಾ? So the some chemical reactions are feasible means they do occur but are so slow, but the rate of the reaction is very 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 slow. The rate of the reaction is very very slow kinetically. If the reaction is very slow kinetically means the rate of the reaction is very slow, that at lower voltages ಎಷ್ಟು ಸ್ಲೋ ಇರುತ್ತಂದ್ರೆ at lower voltages these do not seem to occur. So ಒಂದಿಷ್ಟು ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಇರ್ತವೆ, ಆ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ನಾನು ಅದರ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಪ್ರಾಪರ್ಟಿನ ಸ್ಟಡಿ ಮಾಡಿದ್ರೆ the chemical reaction for which delta G is equals to negative, ಯಾವ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ವ್ಯಾಲ್ಯೂ ನಲ್ಲಿ ಡೆಲ್ಟಾ ಜಿ ನೆಗೆಟಿವ್ ಇರುತ್ತಲ್ಲ ದೋಸ್ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಡೆಫಿನೆಟ್ಲಿ ಆಕರ್, ಅವು ಹಾಗೆ ಆಗ್ತವೆ. ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಅಂತೂ ಹಾಗೆ ಆಗ್ತವೆ. ಬಟ್ ಪ್ರಾಬ್ಲಮ್ ಏನಂತಂದ್ರೆ ದೇ ಆರ್ ಕೈನೆಟಿಕಲಿ ವೆರಿ ಮಚ್ ಸ್ಲೋ. ಕೈನೆಟಿಕಲಿ ವೆರಿ ಮಚ್ ಸ್ಲೋ ಅಂತಂದ್ರೆ ಏನು, ನಾನು ಒನ್ ಡೇ ಎಲ್ಲ ಆ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಮಾಡಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ 1 day ವೇಟ್ ಮಾಡಿದಾಗ 1 ಗ್ರಾಮ್ ಆರ್ 1 ಮೋಲ್ ಆಫ್ ದಿ ಕಂಪೌಂಡ್ ಕ್ಯಾನ್ ಬಿ ಆಕ್ಸಿಡೈಸ್ಡ್ ಆರ್ ರೆಡ್ಯೂಸ್ಡ್. ಅಷ್ಟು ಸ್ಲೋ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೆ. ಹೌದಾ? ಸೊ ಎಷ್ಟು ಸ್ಲೋ ಆಗ್ತಾವ ಅಂತಂದ್ರೆ ಆ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ ನನಗೆ ಏನ್ ಅನ್ಸುತ್ತೆ, ಅದು ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಆಗ್ತಾನೆ ಇಲ್ಲ ಅಂತ ಅನ್ಕೋಬೇಕು ನಾನು, ಆ ತರ ಅನಿಸ್ಬಿಡುತ್ತೆ. ದೇ ಡು ನಾಟ್ ಸೀಮ್ ಟು ಆಕರ್. we can feel that they are not occurring, the chemical reaction is exactly not occurring in the cell. We can feel like that. So the slowness of electrode reaction, if the reaction is very much slow, the slowness of that electrode reaction creates electrical resistance at the electrode surface. Suppose ಆ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಈ ಎಲೆಕ್ಟ್ರೋಡ್ ಮೇಲೆ ಆಗುವಂತ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಬಹಳ ಸ್ಲೋ ಇದ್ದಾಗ ಏನಾಗುತ್ತಂದ್ರೆ the slowness can create electrical resistance on the electrode. ಈಗ ನಾವು ಈ ಕರೆಂಟ್ ವೈರ್ಗೆ ನಾವು ವೈರನ್ನ ಜಾಯಿನ್ ಮಾಡಿದಾಗ ಅಲ್ಲಿ ಕಾರ್ಬನ್ ಬಂದಿದೆ ಅಂತಾರೆ ಗೊತ್ತಾ. ಸೊ ಲೈಕ್ ದಟ್ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಸಪೋಸ್ ನಮ್ಮ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಸ್ಲೋ ಆದರೆ ಆ ಎಲೆಕ್ಟ್ರೋಡ್ಗೆ ಏನು ಬಂದ್ಬಿಡುತ್ತೆ, ಎಲೆಕ್ಟ್ರಿಕಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಬಂದ್ಬಿಡುತ್ತೆ. ದಿಸ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಅಗೇನ್ ಡಿಕ್ರೀಸ್ ದಿ ರೇಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್. ಹೌದಾ? ರೇಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಕಡಿಮೆ ಇರುತ್ತೆ, ಅದಕ್ಕಾಗಿ ಏನು ಬರುತ್ತೆ, ಅದಕ್ಕೆ ಎಲೆಕ್ಟ್ರಿಕಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಬರುತ್ತೆ. ಮೀನ್ಸ್ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಆಗೋದೇ ಇಲ್ಲ. electrical resistance at the electrode surface. To make them occur, ನಾನು ಏನು ಮಾಡಬೇಕು, however I want to get that reaction, ಆ reaction ಮಾಡಲೇಬೇಕು. However, to make them occur, them means what? This them indicates the slow reaction. The chemical reactions are very much slow. To make them occur, some extra potential is needed. Some extra potential, I have to add some extra potential needed than their theoretical value. See here, for each and every chemical reaction we have got some electrode values, electrode potential values. But if there is a formation of electrical resistance at the surface, to make those reactions occur we have to apply some extra potential which is higher than the required value. So the extra potential is required, needed than their theoretical value. This extra potential is called as over voltage. The added extra potential is called as over voltage or over potential. That is called as over voltage or over potential. So here to be sum of ನಾನೊಂದು ಎಲೆಕ್ಟ್ರೋಡ್ ರಿಯಾಕ್ಷನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಆ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೆ, ಹೌದಾ? ಬಟ್ ಯಾವ ತರ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಇಟ್ ಇಸ್ ವೆರಿ 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 ಸ್ಲೋ. ಸೊ ಆ ಸ್ಲೋ ಆಗೋ ಸಲುವಾಗಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಆ ಎಲೆಕ್ಟ್ರೋಡ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಏನಾಗಿಬಿಡುತ್ತೆ, ಎಲೆಕ್ಟ್ರಿಕಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಗಿಬಿಡುತ್ತೆ, ಹೌದಾ? ಸೊ ನಾನು ಏನು ಮಾಡಬೇಕು, ಆ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಮಾಡಲೇಬೇಕು. ಅದಕ್ಕಾಗಿ ಏನು ಮಾಡಬೇಕು, ಆ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಮಾಡೋಕೆ ಎಷ್ಟು ನಂಗೆ ವೋಲ್ಟೇಜ್ ಬೇಕಲ್ಲ ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ವೋಲ್ಟೇಜ್ ಹಾಕಿದಾಗ ಮಾತ್ರ ಏನಾಗುತ್ತೆ, ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೆ. ನಾನು ಎಕ್ಸ್ಟ್ರಾ ವೋಲ್ಟೇಜ್ ಯಾಕೆ ಆ್ಯಡ್ ಮಾಡಬೇಕು? ಟು ಓವರ್ಕಮ್ ದಿ ಎಲೆಕ್ಟ್ರಿಕಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್, ಹೌದಲ್ವಾ? ಸೊ ದಟ್ ಆಡೆಡ್ ಎಕ್ಸ್ಟ್ರಾ ವೋಲ್ಟೇಜ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಓವರ್ ವೋಲ್ಟೇಜ್ ಆರ್ ಓವರ್ ಪೊಟೆನ್ಷಿಯಲ್. ನಂಗೆ ರಿಕ್ವೈರ್ಡ್ ವ್ಯಾಲ್ಯೂ ಎಕ್ಸ್ ಅಮೌಂಟ್ ಇರುತ್ತೆ, ಬಟ್ ನಾನು ಏನು ಮಾಡಬೇಕು, ಐ ಹ್ಯಾವ್ ಟು ಸಪ್ಲೈ ದಿ ವೋಲ್ಟೇಜ್ ಹೈಯರ್ ದ್ಯಾನ್ ಎಕ್ಸ್, ಹೌದಾ? ಸೊ ನಾನು ಎಷ್ಟು ಎಕ್ಸ್ಟ್ರಾ ಸಪ್ಲೈ ಮಾಡ್ತೀನಲ್ಲ ವೋಲ್ಟೇಜ್, ದಟ್ ಸಪ್ಲೈಡ್ ಎಕ್ಸ್ಟ್ರಾ ವೋಲ್ಟೇಜ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಓವರ್ ವೋಲ್ಟೇಜ್ ಆರ್ ಓವರ್ ಪೊಟೆನ್ಷಿಯಲ್. ಸೊ ಐ ಥಿಂಕ್ ಇದು ಕ್ಲಿಯರ್ ಆಯ್ತು ಅನ್ಕೋತೀನಿ ನಾನು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಲೆಟ್ಸ್ ಸಿ ಸಮ್ ಎಕ್ಸಾಂಪಲ್. ನಾನು ಇಲ್ಲಿ ಏನೆಲ್ಲ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ದೀವಲ್ಲ, ಬೇಸ್ಡ್ ಆನ್ ದಿಸ್ ವಿ ಕ್ಯಾನ್ ಸ್ಟಡಿ ಸಮ್ ಎಕ್ಸಾಂಪಲ್. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, electrolysis of molten NaCl gives sodium metal and chlorine gas as the product. ಸೊ ನಾನು ಮೋಲ್ಟನ್ NaCl ತಗೊಂಡು ಎಲೆಕ್ಟ್ರೋಲೈಸಿಸ್ ಮಾಡಿದರೆ ಏನು ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ನಮಗೆ? ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ sodium metal as a product and chlorine gas as the product. Here I will write the process. So here let us consider this is my electrolytic cell. In this cell I will keep two electrodes. Here I will take two inert electrodes. Generally I will take platinum electrodes. Here I have taken platinum electrodes, and here I have kept the electrolyte. Which electrolyte I have taken? Here I have taken molten NaCl. The molten NaCl means what? The solution contains only Na plus ions and Cl minus ions. Molten NaCl means what? Then sodium chloride ತಗೊಂಡು ಅದಕ್ಕೆ ಏನು ಸ್ವಲ್ಪ heat ಮಾಡಿದ್ರೆ it melts. Sodium chloride melts. That liquid is called as molten NaCl. Means that in my solution only Na plus ions are there and Cl minus ions are there. ನನ್ನ ಸೊಲ್ಯೂಷನ್ ತಗೊಂಡ ಸೊಲ್ಯೂಷನ್ ಏನಿದೆ, ಓನ್ಲಿ Na plus ions ಇದಾವೆ and Cl minus ions are there here. So let us take this as my anode, this is as cathode. Here negatively charged, it is positively charged. Okay, here at cathode which reaction takes place? Do you remember? Please remember, always at cathode reduction takes place and always at anode oxidation takes place, isn't it? So in between sodium ions and chloride ions, which one can undergo reduction? Which ion can undergo reduction? Sodium undergo reduction and chloride undergo oxidation. Means the reduction of sodium takes place at the cathode and oxidation of chloride takes place at the anode. So here at cathode sodium ion undergo reduction and it is produced as sodium metal. ಈ ಸೋಡಿಯಂ ಅಯಾನ್ ಏನು ಮಾಡುತ್ತೆ ಅಂದ್ರೆ ಈ ರಿಡಕ್ಷನ್ ಆಗಿಬಿಡುತ್ತೆ, ಇಲ್ಲಿ ಬಂದು ಕ್ಯಾಥೋಡ್ ಮೇಲ್ಗಡೆ ಬಂದು ಸೋಡಿಯಂ ಅಯಾನ್ gets the electron from the cathode as a reward and it is reduced to give sodium metal, and the chloride ion move towards the anode and loses the electron and it is converted into chlorine gas according to this equation. This is the equation taking place at the anode and this is the equation at the cathode, isn't it? So this is in case of our solution contains molten NaCl. If the solution contains molten NaCl, sodium is produced at the cathode and chlorine gas is produced at the anode. Okay, so let us see some the very same example in different manner. But during the electrolysis of aqueous solution of NaCl, ನಾನು ಏನು electrolyze ಮಾಡ್ತೀನಿ ನಾನೀಗ aqueous solution. Aqueous solution of NaCl means what? Aqua means what? Water. Now I am going to electrolyze solution. Which solution? When sodium chloride is dissolved in water, means it is called as aqueous solution. So now my solution is aqueous solution, isn't it? So aqueous solution means what? Now my solution contains how many ions? My solution contains Na plus ions because it contains NaCl, so it contains Na plus, and also it contains Cl minus. It contains solvent molecules, isn't it? Solvent molecule, water molecules are there, and also it contains some of the ions produced by water. What are those ions? Those are H plus ions and OH minus ions. See here, the real picture starts now. Here, this solution contains Na plus ion, H plus ion, Cl minus ion, OH minus ion. So these 4 ions are there in the solution along with the solvent molecule. Now I want to electrolyze this solution. What will happen? What I am going to get? What are the products may be formed at the cathode and anode? Let us see. Aqueous solution of NaCl. During the electrolysis of aqueous solution of NaCl, the product formed are NaOH, chlorine gas and hydrogen gas. How? How come it is possible? Here I have taken NaCl, here also NaCl. Here I have taken molten NaCl, so the products are sodium metal and chlorine gas. Here also I am going to take sodium chloride only, but here the sodium chloride is dissolved in water. In this condition, the products are sodium hydroxide, chlorine gas and hydrogen gas. And let us see how these can be formed in the electrolysis. Okay, so here, so this is the I think you might be know about this reaction, the formation of a sodium hydroxide by using sodium chloride brine solution. Okay, so here at anode oxidation reaction takes place, at cathode reduction reaction takes place. Means, so which are the ion which can undergo reduction? Here we have got 2 type of ions. They can undergo reduction. First one is sodium ion, second one is hydrogen ions, protons, isn't it? So at cathode 2 reaction may occur. The first one is reduction of sodium to give sodium metal and reduction of hydrogen to give hydrogen gas. Here at cathode sodium is reduced to give sodium metal, hydrogen is reduced to give hydrogen gas. These 2 reactions do not take place simultaneously, isn't it? Either one of them takes place. So now we have to identify which reaction can take place at the surface of a cathode. That is a task. Okay. Let us write sodium. For sodium, reduction of sodium ions, the electrode potential is minus 2.71 volt. And for the reduction of protons or H plus ions, the reduction potential or cell potential is 0.00 volt, because here the standard hydrogen electrode, in case of standard hydrogen electrode, we have studied that the standard reduction potential of hydrogen is taken as standard. It is a reference standard and the value is 0 volt, isn't it? And we know that which ion can undergo reduction easily among sodium and hydrogen, which can undergo reduction easily. And I think you must be remembered that the ion or the compound whose electrode value is higher, it can easily undergo reduction. Whose electrode potential value is lower, it can easily undergo oxidation, isn't it? So among them, which can undergo easily, here the value is minus 2.71 volt, the value is 0.00 volt. Here 0 is greater than minus 2.71, isn't it? Higher the value of electrode potential, easier is the reduction at the cathode. So which reaction to be occur at the cathode? Yes, the reaction occur at cathode is this one. Which one? This one. The hydrogen undergo reduction to give hydrogen gas. And please remember, during the electrolysis of aqueous sodium chloride solution, sodium metal do not formed at the cathode. So this reaction takes place. Hydrogen gas liberated at the cathode according to the equation. But H plus is given by water. Here from where H plus came? The H plus came from water. So here water undergo dissociation. Water undergo dissociation to give H plus and OH minus ions. water undergo dissociation or ionization to give H plus and OH minus ions. So here first water undergo dissociation to give H plus and OH minus, then this H plus undergo reduction to give this hydrogen gas. So overall reaction by combining 2 and 3 we can write overall reaction as H2O plus electron gives 1 by 2 H2 plus OH minus, isn't it? So how we can write overall reaction? We can write overall reaction. First write the equation. H plus electron gives 1 by 2 H2, and this equation H2O gives what? It will give H plus OH minus. So what are the common terms here? On the reactant side and product side, H plus cancelled out, and what remains? H2O plus electron gives 1 by 2 H2 plus OH minus. So this is the overall reaction at the surface of cathode. Actually, this reaction takes place at the surface of cathode. Here, this reaction takes place in the solution, and when water undergo dissociation, it will give H plus, and these H plus ions undergo reduction at the surface of cathode. So the overall reaction can be written like this. Now I have written overall reaction. Water plus electron gives hydrogen gas and OH minus ions. So this is the story at cathode. And what about at anode? So let us see at anode. At anode, which reaction takes place? At anode, oxidation reaction takes place. So at anode, here the ion must undergo oxidation. Oxidation reaction takes place at the anode. Here the role of sodium is over, the role of H plus is also over. The remaining ions are Cl minus and OH minus. So we can take OH minus, instead of OH minus we can directly take water, because OH minus is produced by water, isn't it? So at the surface of anode there is a possibility of two reactions. Which one is the first reaction is the oxidation of chlorine to give oxidation of chloride ions to give chlorine, and the oxidation of water to give oxygen and hydrogen ions and electrons, isn't it? At the surface of anode, two reactions may occur. The first one is oxidation of chloride ions, and second one is oxidation of water. Here for this reaction, for the first reaction, the electrode potential is 1.36 volt. 1.36 volt. And for the second reaction, the electrode potential is 1.23 volt. And we know that, what we know? We know that lower the value of electrode potential, it is easier to oxidation. Means the ion can easily oxidize. It can undergo oxidation. Higher the value of electrode potential, it is easily undergo reduction, isn't it? So at anode we have to consider lower value of electrode potential, because we have to consider oxidation, isn't it? So the ion for which lower the value of oxidation potential, it can undergo oxidation easily. See the values 1.36 and 1.23. Which one is higher? 1.36 is higher, 1.23 is lower. Means at anode, at the surface of anode, this reaction must take place. Which reaction? Equation 5. Reaction 5 means water should undergo oxidation to give these many ions. So it is theoretically expected, theoretically given. Theoretically we can guess that this reaction takes place at the surface of anode, but we are wrong. Why? Because here, but due to the over potential of oxygen, to form this oxygen, over potential takes place. Over potential means what? Here this reaction is very much slow. The oxidation of water is very much slow, kinetically very much slow. For those reactions, what they will cause? They will cause electrical resistance at the surface of anode. So to outcome that electrical resistance, we have to supply extra voltage. because of this much voltage, this reaction do not take place. At lower voltage, this reaction do not occur. There were only two possibilities: the possibility of formation of chlorine gas and possibility of formation of oxygen. But due to over potential, this reaction do not occur. And what remains? The remaining is this one. So this reaction takes place at the anode. Actually ನಮಗೆ ಈ ರಿಯಾಕ್ಷನ್ ಆಗಬೇಕಾಗಿತ್ತು, ಬಟ್ ಏನು ಪ್ರಾಬ್ಲಮ್ ಆಯಿತು ಅಂತಂದ್ರೆ ಇದಕ್ಕೆ ಏನು ಬೇಕು? ಈ ರಿಯಾಕ್ಷನ್ ಆಗಬೇಕಾದ್ರೆ ಓವರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಬೇಕು. ಯಾಕೆ ಓವರ್ ಪೊಟೆನ್ಷಿಯಲ್ ಬೇಕಂದ್ರೆ ಈ ರಿಯಾಕ್ಷನ್ ಎಷ್ಟು ಯಾವ ತರ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಇಟ್ ಈಸ್ ವೆರಿ ಸ್ಲೋ ರಿಯಾಕ್ಷನ್. ಕೈನೆಟಿಕಲ್ ಎಷ್ಟು ಸ್ಲೋ ಇರುತ್ತೆ ಅಂದ್ರೆ ಆ ರಿಯಾಕ್ಷನ್ ಆಗ್ತಾ ಇದೆ ಅಂತ ನಾವು ಗೆಸ್ ಮಾಡೋಕ್ಕೂ ಆಗೋದಿಲ್ಲ, ಅಷ್ಟು ಸ್ಲೋ ಇರುತ್ತೆ. ಹೌದಾ? ಅದಕ್ಕಾಗಿ ಏನ್ ಮಾಡ್ಬೇಕು ನಾವು ಅದನ್ನ ಆ ಸ್ಲೋ ಆಗೋ ಸಲುವಾಗಿ ಏನಾಗುತ್ತೆ, ಆ ಎಲೆಕ್ಟ್ರೋಡ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಎಲೆಕ್ಟ್ರಿಕಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಆಗಿಬಿಡುತ್ತೆ ರಿಯಾಕ್ಷನ್ ಸ್ಲೋ ಇರೋ ಸಲುವಾಗಿ. ಆ ಎಲೆಕ್ಟ್ರಿಕಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ನ ಓವರ್ಕಮ್ ಮಾಡೋ ಸಲುವಾಗಿ ಏನ್ ಮಾಡ್ಬೇಕು ನಾವು? ಎಕ್ಸ್ಟ್ರಾ ಪೊಟೆನ್ಷಿಯಲ್ ನ ಆಡ್ ಮಾಡಬೇಕು. ಹೌದಾ? ಬಟ್ ನಾವು ಎಕ್ಸ್ಟ್ರಾ ಪೊಟೆನ್ಷಿಯಲ್ ಆಡ್ ಮಾಡ್ತಾ ಇಲ್ಲ ಈ ರಿಯಾಕ್ಷನ್ ಅಲ್ಲಿ. ಬಿಕಾಸ್ ಆಫ್ ದಟ್ ರೀಸನ್ ದಿಸ್ ರಿಯಾಕ್ಷನ್ ಡು ನಾಟ್ ಟೇಕ್ ಪ್ಲೇಸ್. ಇದು ಎಕ್ಸ್ಟ್ರಾ ಪೊಟೆನ್ಷಿಯಲ್ ಆಗಿದಾಗ ಮಾತ್ರ ಈ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೆ. ಹೌದಾ? ಅದಕ್ಕಾಗಿ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ ಈ ರಿಯಾಕ್ಷನ್ ಆಗಿಲ್ಲ ಅಂತಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಯಾರಾಗಬೇಕು? ಈ ರಿಯಾಕ್ಷನ್ ಆಗಬೇಕಾಗಿತ್ತು ನಮಗೆ, ಈ ರಿಯಾಕ್ಷನ್ ಆಗ್ಲಿಲ್ಲ. ಹೌದಾ? ಸೊ ಈ ರಿಯಾಕ್ಷನ್ ಆಗಿಲ್ಲ ಅಂತಂದ್ರೆ ಈ ಉಳಿದವರು ಯಾರು? ಈ ರಿಯಾಕ್ಷನ್. ಹೌದಾ? ದಿಸ್ ರಿಯಾಕ್ಷನ್ ಡೆಫಿನೆಟ್ಲಿ occur. If this reaction did not occur, this reaction definitely occur. Means at anode the reaction takes place, it is this one. Okay, cathode surface ಅಲ್ಲಿ ಈ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೆ, which one? This one. And at the surface of anode this reaction takes place. So what we can write? We can write overall reaction. We can write overall reaction is NaCl plus H2O gives Na plus OH minus. These two combine to give NaOH and hydrogen gas and chlorine gas, isn't it? Okay, Na plus is formed in the aqueous solution, OH minus is also formed in the solution. So these two are remain in the solution. This reaction takes place at the surface of cathode, this takes place at the surface of anode. Means at the electrodes these two occur, in the solution this reaction occur. Who can sum up this reaction here? How we can get overall reaction? I will write all the chemical reaction taking place in the cell. First we have taken NaCl, isn't it? We have taken NaCl, solid NaCl. It is dissolved in the water. On dissolution what it will give? Na plus Cl minus, isn't it? First we have taken NaCl and we have dissolved this in water. Okay, I am going to get Na plus and Cl minus. And at cathode, so what is the overall reaction taking place at cathode? This one, H2O plus electron, H2O plus electron, it will give 1/2 H2 plus OH minus. Okay, at anode, at the surface of anode this reaction takes place. Cl minus will give, write clearly, Cl minus will give 1/2 Cl2 plus electrons. Now what we can do is we can cancel out the common terms which are present on the reactant side and product side. Electron is here, electron is cancelled out. Cl minus is here, Cl minus is also cancelled out. So what are the possible remaining things present in this equation? We can write them. On the reactant side NaCl is remaining plus water. It will give what? It will give Na plus in the aqueous solution plus OH minus in the aqueous solution plus 1/2 H2 plus 1/2 Cl2. So this is the entire story taking place, the entire chemical reaction, overall chemical reaction taking place in case of aqueous sodium chloride, isn't it? So by by this concept we can come to know that the formation of product during electrolysis depends upon the nature of electrolyte. In first case we have taken only molten NaCl and we got sodium metal and chlorine gas as the product. But in second case we have taken the aqueous solution of sodium chloride. For that we have got the what we got? We got sodium hydroxide as a product, caustic soda as the product, sodium hydroxide, hydrogen gas and chlorine gas. We got sodium hydroxide, chlorine gas and hydrogen gas as the product in case of aqueous sodium chloride. Okay, so this is the product of electrolysis. By taking different type of electrodes and different type of electrolytes, the product formed is also different. Okay, I hope this video is helpful to you. Thank you.